All right, so who is using containers right now in some kind of project? And who is planning on using containers on a project? Great. Okay, so we have a bit of a mixed audience here. Some are using, some are not. So we'll just start from the very beginning. Should be fine. Oh, everything works out. Perfect. So, a little bit about myself. My name is Timo Kaleva. I'm from a small consulting company called Sofecta. We were established in 2017. We are situated in Helsinki. Currently, we have 6 people working, completely staff-owned. Our primary focus is and demo effects, if there ever was one. I currently have a blue screen on my laptop, so that's why the screen is frozen. Right. So yeah, just this yeah. So this can actually happen. So beautiful. Right. Right. So what I'm planning on talking about is the different container hosting options in Azure. There are multiple ways you can host your own Docker containers, and I was planning on going through them and talking a bit about why you would want to maybe choose one over the other, or simply how you could get started with it, which would be much easier if I had something to show. But okay, let's start off by listing the first option, container instances, which is basically that is the easiest option, the fastest option to get started, which is, as it might sound like, it's just a hosted instance of a container within Azure. So you don't need to worry about any of the resources or anything like that running there. You basically select, okay, I want this many cores, I want this much memory running in it, and I want this image to be running with that container. There's one caveat though: you cannot scale. It does not scale at all. So basically, once you provision or deploy that container, you are stuck with that until you redeploy. And that is also going to be the similar theme with another container solution we are going to be covering a little bit later. But yeah, that is the first one. Oh, 100% complete. Beautiful. Okay, so the next one. Let's see if I can remember the actual order I was in. Right, the web app for containers. How many of you have used app services or web apps in Azure? Okay, so good. Those are also I favorite web apps a lot. I've used them a lot in the past years because I just love how easy they make to be able to deploy sort of very basic web application, even more complex web application. They give you the ability to get a turnkey authentication, get a course headers, everything. You can get the environment variables set up, everything. So it gives plenty of nice things, and it can also bring that over for your containers. Same thing. So what you can do is once you create the web application or the app service, you can select you want to run it as a Linux-based app service, which will then enable you to select that, okay, instead of me personally manually deploying something code to run over there, I will just point out that, okay, there is my container repository. That is going to be the image I want to run in there, and please just run it. And it will handle the rest. It will go and fetch your image, and it will run and give you all the nice features the app services provide. So back to business. So what we covered so far. All right, so this is actually what I forgot completely, but I figured it might not be that important as most of you had some sort of idea what containers were. But quick recap. So container, how to say it best? So well, a set of your application running on a standard set of tools and system libraries that is defined by the base image, which is differentiated from a virtual machine by the notion that virtual machine usually when you deploy a virtual machine, you are dedicating all the hardware of that virtual machine into running your application and all the resources. But in a container, what happens? Let's take out the sounds. In a container, you basically use a virtual machine to run multiple containers because they are using the OS level to separate all these processes, and they all have their dependencies and everything the application needs to run within that container. So it's an isolated environment, so there's not going to be the old school type of DLL hell or similar situation, or something you could run into these days, which with Node, for example. So I think some people might have run into a situation where you have a 6-month-old Node application that simply doesn't work because you happen to run npm install and none of the libraries work at all anymore. So this is handling that kind of issues. So here we have the container instance. And as you can see, it's very easy to get started. So basically all you need to do, you have your subscription, you give it a name, select region, and just select the image. The image is right there, down there. That is fetching the Hello World image directly from the Docker Hub. But you can also use your own private repository if you have such a available. So what you get a container instance. It's very bare bones solution, but still what you get access control, you get the ability to stop, restart, delete. It is running at that point. You can see all the CPU usage, you can see the memory, and you can even set alerts if you happen to be running the CPU usage is passing certain thresholds. You want to get an alert, you can set up alert using Azure's own tooling, which is well supported. You can also use managed identities, but I think Jonas is going to be talking about more about those later on. The second option, what if you wanted more? What if that was not enough? So the second one I was talking about is the web application. It's using the app services to run your containers. So this is how it looks like when you go create a new app service. You select a Linux container option, and then you can, as you can see, I cropped out other options, but there were also the options to use Docker Compose, and I believe it was AKS that was also in that same view. But the ability to run single container from either running select samples from Azure or Azure Container Registry, which we will cover later, Docker Hub, or private registry. So if you have some sort of registry available for your current existing images, it's very easy to get them running and see if they happen to work. If everything works, just doesn't take more than that to try it out. And what does it give you? For example, custom domain abilities, integrated CI/CD pipelines, integrated AAD authentication, or more like turnkey authentication. If you have used app services, you've probably seen that the authentication, one of the selections for those app services there, where you can select that, okay, in order for end user to be able to access this application, they will need to be authenticated with one of these identity providers. Which is very, very nice. You don't need to, as an application developer, you don't need to worry about that sort of thing at that point. And of course, custom certificates as well. And as well as we covered earlier, most of the functionality provided for regular app services is available for you. Some of them are limited outside, but those are going to be most of the time edge cases, which hopefully you will need. And if you do need, then this is not the solution for you. But okay, so what else is there? So now we've covered container instances and web applications. These two are likely to be the easiest way to try out, but we have other options as well. So okay, those were targeted if you want to run some kind of web application, UI. So what about if you want to run some kind of background logic? Now we come to functions. Functions can run Docker containers. The only limitation is that you will need to build your function based on the base image of a Azure function, which is, but that allows you to easily develop it locally before you have to deploy it all the way to Azure. And it's also, if your whole DevOps process is built around containers, then that is a good way to keep everything uniform. Other option, how many of you know Azure Batch? Very few, but great, a few knew. So Azure Batch, so if you do not know, it is meant for large-scale CPU-intensive processes. Well, I think the best example I can think of right now would be the rendering and such, which are tasks that can be partitioned into small holes and distributed, for example, to 1,000 VMs running the same thing. Each of those VMs would be performing one part of that calculation or operation, return the data back, and you would be getting the whole picture. And those you can also be using containers to run that logic. So now we get into somewhere more interesting. So the previous parts covered the cases where you are basically running, okay, I'm doing some little development, or I have some old software running somewhere that is containerized, I just need to get it somewhere. But okay, how about when we actually want to do some kind of larger software that we want to develop into a production environment? Then maybe the scale of those is not going to be enough. So that is when we are talking about container orchestration. And that is when we come to talk about lifecycle management concerning provisioning, deployment, scaling, redundancy, monitoring, isolation. And this is basically your way of being able to handle larger collective of the containers in a single I'm losing the train of thought here. In a concise manner, just say like that. And even for this, Azure has multiple ways you can do this. Actually, there were even more, but one of the options has been deprecated this far. So there used to be also Azure Container Services, but that has been deprecated in favor of Azure Kubernetes Services. But first one we will be covering is Service Fabric. How many know Service Fabric? You. So how Service Fabric came to Azure, it's basically providing scalable software service for microservices. You use its either you can you don't need to use its own programming models, but you could use that to create scalable, resilient software. What it does, it creates a cluster of VMs in the background. You can upload your own software in there, and then you can also set up, just like in any container clusters, you can set up health checks, see if they are running in there, and you can also do resource monitoring. You can see if they need to be scaled up, scaled vertically, horizontally, how much they need resources. Lately, they have added the ability to also run containers in Service Fabric. So that is why I included it. But unless you are actually using it for the application development as well, I really can recommend just for running the containers, because I think AKS is still the superior solution compared to this. But if you are already committed to Service Fabric usage, then it's fine to be using that as well. No problem. Also, I'm not quite sure if this, it wasn't a long time ago since I checked this, but Linux version of Service Fabric is open source. Windows version, not quite so much. I believe that is still a work in progress. There hadn't been a lot of updates lately. And that is the tooling, internal tooling Microsoft is currently using to power many of the core services in Azure. And here we have the big boy, AKS. I think if you know something about containers, you have heard about AKS, which is pretty much the de facto orchestration service currently available for Docker containers in general. So what AKS does, it provides you, when talking about AKS, I'm interchanging it with Kubernetes. Kubernetes is the actual de facto standard for managing. AKS is Azure's version of the managed Kubernetes environment. It very neatly integrates to many of the IaaS offerings Azure has, and it has a large community. So there's plenty of information available, plenty of training available. You most likely know someone who is very adept at it. At least they know how to run a local Kubernetes cluster, and they can use that same knowledge to operate a cluster in Azure as well. Because Azure portal allows you to open up a cloud shell, which will allow you to use the Kubernetes control shell programs as well. You can also do that locally, but in case of larger installations, you may have isolated the actual cluster from outside web. So you may have only opened up certain pathways from a jump box, for example, which was the case in one of the recent projects we had. They wanted to have very secure environment. So basically what had to happen was that the AKS lived inside its own network, which was accessible from the outside only through a single jump box. Logical isolation, which is basically shorthand in this case for namespaces, allows you to utilize the same cluster. You don't need to have own cluster for every single development team. For example, you can share the same cluster, share the headaches. And dev spaces is also, it's a relatively new feature, but if you are developing for AKS, you definitely should be looking that out. It makes it so much easier to onboard new developers for your project, especially if it's microservices. You have lots of smaller services that need to be running as a container somewhere. So instead of them having to deploy their own environment, then start deploying each container separately. So this makes it much easier. But there's the big caveat. Just as in container instances, you are currently locked to the node size you selected in the beginning when you deploy the AKS environment. And that is very well. And this means that the AKS cluster nodes, not the pods. And this is bad, especially in environments where you can run multiple containers that have very different resource intensiveness. Let's just say it like that. For example, one project we had was where they were supposed to be running in the same cluster Elasticsearch and as well as some smaller microservices, which are two completely are very different in their resource intensiveness. The Elasticsearch, I think the basic requirement was something like 4 gigabytes of memory, at least 2 vCPUs and something, and it was minimum, no, actually, sorry, it was 8 gigabytes, and for the microservices, like 1 gigabyte, 1 vCPU. So you have to run all of that in the same nodes. What you can do in AKS, though, is you can alter which parts use how much resources in which nodes they are running on. So there is some leeway, but that is going to be requiring some manual work. And if you want to, yeah, and also you can add more nodes, but that is still going to have to be a manual work. And as mentioned, Azure also has its own container registry. So if you have some private images, container images, you do not want to share with the world, you can provision yourself Azure Container Registry and upload your images there instead of a Docker Hub, for example, or other self-hosted solution. And this is also supported very well by all the Azure services. So most of them have the option of simply selecting either typing out the Docker Hub image, or you can just start browsing the options available in your container registry, which is located in the same subscription. And those are the majority of the container hosting solutions in Azure. I'm not saying this would be the only ones, because it seems like every few weeks there comes a new service that somehow supports containers in some capacity. But I think these would be covering the most commonly used scenarios. I had something I wanted to show you earlier, but the unfortunate blue screen slightly came in the way. While I open that, does anyone have any questions? So either I've been nobody cares, or it's been completely clear for everyone. So that's good. Just a moment.
I can ask you a question if you want.
Sure, go ahead.
Can you give us, if possible, an example of where, in what real-life cases you're using it, like some sort of project or company that it's having this solution? Or
Well, no. Well, I think in majority, the web app for containers and the container instance, those are run mostly in the development capacity. We haven't done projects where we've done a production environment with those, but we have done it with AKS. So AKS so far has been the one we have leaned towards. And currently I am working on one project where we are deploying AKS, which is the one I described with the isolated VNet, and that is currently running about this. That also has Elasticsearch running in it, because that was a project where the company that contracted us, they were migrating in from AWS, and AWS had hosted Elasticsearch, which Azure does not. So what we had to do is we had to containerize the Elasticsearch and have it running in the background as well. And then also what we had to do, create load balancers between all these parts that were in there. They had about 10 custom parts running in their solution as well. So yeah. So yeah, mostly AKS for the actual slightly larger scale production use and large scale production use. You can use the web app for containers for running websites or something, which is mostly limited to one container. But whenever you go, you have a solution that requires multiple containers, I would suggest you use an orchestrator. So, but yeah, they're great for developing and testing phases. Okay, let's see what we have here. As I lost everything in the blue screen, I will just quickly show that here I have a web app for container demo, which is running on app service. So as you can see, it looks just like the regular app service, with the only change being that there's a few things that are grayed out, extensions, app service editor, which are quite understandable omissions. But if we go here, we can see it actually responds, and that Nginx is running inside the container that is running inside the app service. And what else we had here? There we also have the function, which I mentioned. Same thing. As you can see there, the URL changes. This is what I deployed as well. So this is the function that is operating the container, which is also a nice function to have. And as you can see here, everything is read-only because you can't really update the container from here. And here we have container instance. Unfortunately, the AKS, I have it running, but there's nothing really going on in there, so there's not much to see. And this is not running either for some reason. I think this also has something to do with the same thing that Sake mentioned, that yeah, some issues currently in Azure. Now it's of the opinion that there are no resources available. There are no Linux resources available for some reason in that data center, so that's why it's down, which makes sense. All right. I think, unless somebody wants to see more of these, but I think that's about that covers the most cases. Service Fabric I did not provision because it's a bit beefy installation. I don't have the developer credits in my account enough to run it because it requires something like 3 VMs just to be able to create it. So it eats up all the credits. Yeah.
So I've never used any containers for anything. So I'm just when you're choosing this kind of infrastructure setup, like what's the kind of sales point of picking your container environments for a production rather than, for example, VMs or like Azure search or something like that?
Well, for containers, I think the immutability of the environment or the basic environment running is one of the main selling points. So you don't need to worry about if something changes under the hoods that your application is running. You always know you have this same set every time, and then you simply put your application on top of it. And what you also do is you bundle all the dependencies what it needs. And also what happens once you go into this container-focused development cycle within your company, you will also start, if you do things that are in the same field, for example, you may start gaining your own base images. So once you start doing similar projects, which may require perhaps some additions to some base image, then you create a base image of that, and then you have one step forward for the next project as well. And the difference between the VM and the container is that a VM is a heavier solution, and it's only for that application. You can run multiple applications, but inside VM there is no isolation between those processes. So there is a theoretical chance that they could interfere with each other. But
so I guess the thing is, if you're using the containers in a developer environment, like you've got the team of devs, and like you said, you've got your node installations and NPM and all those things that break between different versions of Azure.
yeah.
But then, if you then don't use those same things in a production scenario, do you not still have a kind of migration required from that developer container style of work onto a production system anyway, where you then have to
So in a situation where you develop with a container but don't have containers in production.
Yeah, like you're saying you use them all in development, and I have friends of mine who are saying, yeah, it's great for our developer environments, we can spin up new guys and they have a laptop and a container and they've got our software running. It makes it easier if you can run the containers in the production. It's not a requirement. What it just means that all the developers will have the same playground to play with once they get it running on the computer. But there's always going to be the risk. Okay, so what is going to be different with the container environment and the production? So that's something you need to solve within the project. But it does equal playground for all the developers who can trust that it will run on their machine once they get the base image on it.
Quick question. So we usually pay for resources, and apparently when you have application in the container and container inside some kind of orchestration of the system, again, can you tell how much overhead is resource overhead is on the container and infrastructure side? And do we pay for resources? Probably we are not paying for resources just spent by container. We pay for everything, right? It's used also to run the container. So is it like 10%, 15%? How much?
It's there's not really much that much overhead because it's still running. All of these are running VMs behind the scenes. We could see some of them. Actually, I can just go see here. The container itself doesn't cost anything on top of these, but the base infrastructure that is running here, that is still going to cost the same as it would if you were to run it without the containers. So, for example, let's see if we have the. Let's check the app service. And here we have scale up, scale down, and see we see that we still have that same VM as we would in the normal app service. We just have something else running in it, and the function app, as we had to select the Linux running environment. That means we also had to select the app service plan, which is going to cost some just to access. So there's no consumption model for function services in this. And the AKS, for example, AKS itself does not cost anything. That's free. But what does cost are the nodes in the cluster. So that is all up to you how much you want to dedicate resources into that cluster, how much it's going to cost.
So basically all the overhead goes to the containerized model. Kind of that you actually choose to run stuff in the container and you need to support the containers in it. Right? So, as opposed to run application directly on the VM.
Well, I'm not quite sure if I understood the question correctly. If you're talking about if it's a heavy process, if it adds a lot of overhead, is that what you're asking?
Yeah, something like that.
Yeah. So no, it's relatively light process in general sense. It doesn't add much. I don't have anything. I wasn't prepared for a question, so I don't have any figures to show you how it would change. But but as with everything else, it's relatively easy to scale unless you use container instances where you can't scale. But what you can do is, if you have the ARM templates, you can simply deploy multiple instances of certain servers, run them with a certain set, load test, and see how much it would cost you. So that's the best way usually to gauge how much something would cost, because it's hard to say for sure that okay, this is going to cost you this much in Azure, as it's mostly based on how much you actually consume. Yeah.
On the demo you showed, if you run the exact same container on the app service and the function apps.
Yes, I ran the Nginx from Docker Hub.
And on the function example, did it run only while it shows the web page, or is it constantly running on the function app?
It's constantly running. It's the app service plan, so it doesn't really change anything. It's in the standby mode. It's not constantly ticking away, but what does consume it is the app service plan itself. Despite if you don't have any requests coming in, you're still going to have to pay for the certain amount if you have the app service plan. All right.
What,
Yep.
If you think about all the services that are available in Azure, what of those can you wrap into a container, or can you put anything in a container?
Which Azure services you could wrap in a container?
You were talking about you can run, you web application and the data storage that it needs, you can put it in a container
Yeah.
and manage those as a one single unit. But, well, let's say SQL Server, stuff like that, can you put all of those services into a container as well?
Yes, you can put a SQL Server into a container. It's probably not the it's not the best use case. I probably wouldn't do that if it was an option. Well, in the case I was talking about, actually, that was not an option. We are not running SQL Server. We are running Postgres. But that was because they were adamant about having to having a transferable environment. They didn't want to be tied down to Azure in any capacity. They wanted to be able to lift and shift the environment into another Kubernetes environment somewhere else. So yes, you can run SQL Server, and I think there was even there's a ready-made sample somewhere where you can get an ASP.NET Core and SQL Server container ready to run in one of these. Can't remember which. But yeah. But in the real world, I would still, unless you are actually planning on moving away from Azure, now that you're actually investing all this time and effort, I still prefer mixing in the platform services that are available. For example, in the SQL Server, I would use SQL Azure, preferably, but that's just me.
I was just thinking about scenarios where you have a development environment and test environment, even though you have one single instance of your application you are delivering to a customer, for instance.
Yes, it's perfect.
Then you
Yeah.
would wrap all of the, as you were talking earlier about all the dependencies, you would put them in a container, and then you would put it in a test environment, then some staging, and have that exact same application, all the same identical code running in different environments, and then at some point you put it in your production environment.
Yes, that is if that is the wish, you want to be able to have the exact everything running within the containers. Yes, that is completely doable, pretty much. But it's but you can't. These services are not something you can wrap up inside the containers, pretty much. So what you have to do is you need to have a similar service, or for example, with the SQL Server, you need to have the SQL Server separately running, which would be about 2016, I think, at this point.
Yeah, the containers are volatile, aren't they? So I think, I know this is a long time ago, but I read some advice that it was a bad idea to store your data in the container because they can be...
Yes. Yes.
Yeah.
And that is why you don't store any of the data inside the container. That is why you utilize Azure storage for storing the data.
Same as with app service, you can store data on the local disk, but you shouldn't do that.
Yeah, just you can store, but don't expect it to be there when you need it.
All right.
But if you are really into this kind of heuristic mode that you don't want to lock yourself into any kind of external things, then you can configure your kind of AKS deployment in this kind of stateful set mode that you actually have kind of more than 3 copies of that container, and together they are kind of making sure that they always have them on sync, all of that. So kind of essentially all the work that Microsoft is doing with storage, you could do on your own inside the cluster as well. To shoot, really, you don't get the benefits, but if you really want to keep everything in Kubernetes, that's your way.
Yeah. Usually there's some middle ground you can find where there's simply no sense in doing everything in completely puristic fashion. So, but yeah, in the general sense, don't store anything within the container, always outside. All right, that is all. Then, thank you.